Hello students, I am Manoj Kundare, the Assistant Professor of Electronic Science. Welcome back to our e-learning platform. In previous video, we have completed the second unit of the subject Microcontroller Architecture and Programming. In this video, we are going to start the third unit of the subject named as Timer Counter and Interrupts. Let's start our today's topic, Timer Counters of 8051 microcontroller. We know that the 8051 microcontroller have two 16-bit timers and counters named as T0 and T1. The timers are used to provide the specific time delays and the counters are used to count the events. Both the timers T0 and T1 are of 16-bit wide, but our 8051 microcontroller has 8-bit architecture. That means its CPU works on the 8-bit, hence each 16-bit timer is divided into two 8-bit timers named as TH and TL, where TH stands for timer high byte and TL stands for timer low byte. This is the timers of the 8051 microcontroller is shown, in which we know that the timer 0 and timer 1 both are the 16-bit. That means both are starts from D0 to D15. Okay, the timer 0 is divided into two types. The low byte is known as TL0, that means timer 0 low byte, and the high byte is named as TH0, that means timer 0 high byte. Similarly, timer 1 is divided into two types, TL1 and TH1. Okay, now let's start the main topic of this lecture, the TMOD or the timer mode register. It is an 8-bit SFR. The timer 0 and 1 uses the same register called as TMOD to set the various timer operation modes. TMOD is an 8-bit register in which the lower 4 bits are set aside for timer 0 and upper 4 bits are for timer 1. In each case, the lower bits or the lower 2 bits are used to set the timer mode and the upper 2 bits are used to specify the timer operation. The 8051 timer counter has 4 modes and they can be programmed by using SFR called as TMOD or timer mode register. That means the TMOD register is an 8-bit SFR which is used to specify the timer used and its mode. Let's see the structure of the TMOD register. This is the structure of the TMOD register, in which we can see here that the lower 4 bits are identical with the upper 4 bits, where the lower 4 bits are used for timer 0 and upper 4 bits are used for timer 1. The 4 bits are M0, M1, C oblique T bar and gate. Okay, let's see the description about each bit one by one. First of all, let's see the description of or the working of the gate. The bit number 3 and bit number 7 is the gate bit. The bit number 3 is used for timer 0 while the bit number 7 is used for timer 1. I hope you all understand the basic difference here. It is known as the gating control when set. The timer counter is enabled only when the INTX pin is high and the TRX control pin is set. Here the INTX pin means INT0 and INT1 pin. Okay, that means external interrupt 0 and external interrupt 1 pin. In case of bit number 3, INT0 pin is referred, and in case of gate number 7 or bit number 7, the INT1 pin is referred. And the TRX stands for, it is the bit in the TCON register. TRX means TR1 or TR0. Okay, I hope you all understand the INTX pin and TRX pin. The function of the gate is that when gate is equal to 1, for example, let's consider bit number third this gate is equal to 1, it enables timer counter only when the int 0 or int 1 pin is high. That we refer here bit number third, that means timer 0. Hence in that case int 0 pin must be 1 and the tr0 or tr1 pin is set. That means in the same case the tr0 bit must be 1. If we refer the bit number 7, that means if this gate is 1, then in that case the int1 pin must be 1 and the tr1 pin must be 1. Then and then only this timer is enabled. Okay, but when gate is 0, that means when the gate has the value 0, then the timer can be enabled when the tr0 or tr1 bit is set. That means when this tr0 bit is set, then timer 0 is enabled even if the gate bit is 0. Similarly, when the tr1 bit is set, that means tr1 bit is equal to 1, then this timer 1 is enabled even if the gate bit is 0. I hope you all understand the function of the gate bit. Now let's see the next bit, C oblique T bar, or bit number 2 and 6 of the TMOD register. The bit number 2 is used in case of timer 0 and bit number 6 is used in case of timer 1. It is a timer or counter select bit. That means whenever C oblique T bar bit is 1, then it is used as counter, and when C oblique T bar bit is 0, then it is used as timer. Okay, I hope you all understand the basic function of the C oblique T bar pin. Okay, now let's see the next two bits, M1 and M0. M1 and M0. Let's see once again, when M1 and M0 both having value 0, then mode 0 is selected. It is a 13-bit timer mode. When M1 equal to 0 and M0 equal to 1, then mode 1 is selected and it is the 16-bit timer mode. When M1 is equal to 1 and M0 equal to 0, then mode 2 is selected, which is 8-bit auto reload mode. And when M1 and M0 both are having value 1, then mode 3 is selected, which is the split timer mode. Okay, I hope you all understand the basic functions of the pins of the timer mode register. Okay, now let's see the next register. TCON means timer control register. The TCON is an also 8-bit register in which the lower 4 bits are set aside for the interrupts and the upper 4 bits are for timers and counters. It is used to the control operations of the counter and timers in microcontroller. This is the structure of the TCON register, in which the lower 4 bits are used for the interrupts and the upper 4 bits are used for the timers and counters. Let's see the description about each bit one by one. The bit 0 is IT0, bit 1 is IE0, bit 2 is IT1, bit 3 is IE1, bit 4 is TR0, bit 5 is TF0, bit 6 is TR1, and bit 7 is TF1. Let's see the first bit, bit number 7, TF1. It is known as the timer 1 overflow flag. That means it is set to 1 when the timer 1 overflows, otherwise it is 0. That means when the timer 1 overflows, then this TF flag or this bit is set to 1. It is cleared through the software. In the timer 1 overflow interrupt service routine, this bit will be get cleared automatically while exiting from interrupt service routine or ISR. Whenever the TF1 is equal to 1, then the clear flag bit and stop the timer. Okay, that means whenever the timer 1 overflows, then TF1 bit sets. This is the simple basic function of the TF1 bit. The next bit is TR1. It is known as the timer 1 run control bit. When TR1 is equal to 1, the timer 1 starts, and when TR1 is equal to 0, timer 1 stops. The very simple function of the TR1 is given here, that when TR1 is equal to 1, that means when TR1 bit is set, then the timer 1 is set or enabled, and when this bit is having value 0, then the timer 1 is disabled. This timer starting can be done through the software instruction or through the hardware method. For example, when gate is equal to 0, then start timer 1 through the software control instruction TR1 equal to 0. That means when the gate bit of the TMOD register is having value 0, then in that case we also start the timer by setting this timer run bit to 1. Okay. The next bit is TF0, that means timer 0 overflow flag. It is set to 1 when the timer 0 overflows, otherwise it is 0. That means when the timer 0 overflows, then this TF0 bit set. When timer 1 overflows, then TF1 sets. When timer 0 overflows, then TF0 sets. I hope you all get the basic difference between the TF0 and TF1 bit. It is clear through the software. In timer 0 overflow interrupt service routine, this bit will be cleared automatically while exiting from the ISR or interrupt service routine. Whenever the TF0 bit is equal to 1, then clear the flag bit and stop the timer. Okay. The next bit is bit number 4, TR0. It is known as timer 0 run control bit. When TR0 is equal to 1, timer 0 start. When TR0 equal to 0, timer 0 stop. This timer starting can be done through the software instruction or through the hardware method. For example, when gate equal to 0, then we can start timer 0 through the software instruction TR0 is equal to 1. Okay, that means even the bit number 3 or the gate bit in the timer 0 in TMOD register is having value 0, then in that case we also can start the timer 0 by setting the TR0 bit in the TCON register. I hope you all understand. The bit number 3 is IE1, that means external interrupt 1 edge flag. It is set to 1, that means IE equal to 1 when external interrupt 1 is occurred. It is set to 0, that means IE equal to 0 when external interrupt 1 is processed. It is set and cleared by hardware. That means when the external interrupts is occurred, then this bit is set. Okay. The next bit is IT1. It is known as external interrupt 1 trigger type select bit. It is set to 1 by program to enable the external interrupt 1 to be triggered by the following or the falling edge signal. It is set to 0 by program to enable low level signal on external interrupt 1 to generate an interrupt. That means it is used to generate the external interrupt. Okay. The next bit, bit 1 is IE0, that means external interrupt 0 edge flag. It is set to 1, that means IE equal to 0 or sorry IE equal to 1 when external interrupt 0 occurred. That means when the external interrupt occurs, then IE0 bit is set to 1. It is set to 0, that means IE equal to 0 when the external interrupt 0 processed. That means when the external interrupts occurs, we know that there are two pins for the external interrupt, INT0 and INT1. That means when the external interrupt occurs through the INT0 pin, then IE0 pin is set. And whenever the microcontroller goes or process this interrupt, then this IE0 pin is now reset. Okay. I hope you all understand the function of IE0 and IE1 pin. The last bit is IT0, that means external interrupt 0 trigger type select bit. It is set to 1 by program to enable external interrupt 0 to be triggered by falling edge signal. It is set to 0 by program to enable a low level signal on external interrupt 0 to generate an interrupt. That means this bit is used to generate the interrupt. Okay, I hope you all understand all the bits of the TCON register. Let's see the short look on these two registers. The TMOD register is an 8-bit SFR which has total 8 bits. Out of these 8 bits, the lower 4 bits are used for timer 0 and upper 4 bits are used for timer 1. The lower 4 bits are identical with the upper 4 bits. Okay. The gate bit of each timer 0 and timer 1 is used to enable or disable the timer. That means whenever the gate has the value 1 and the pin INTX, that means INT0 or INT1 has the value 1 and TRX, that means this TR1 or TR0 having value 1, then we can start the timer 0 or timer 1. Okay, the C/T bar pin is used to specify the counter operation or the timer operation. The M1 and M0 bits are used to specify the timer modes. There are total 4 timer modes. Whenever M1 and M0 has the value 00, then timer mode 0 is selected. When the M1 and M0 has the value 01, then the mode 1 is selected. When M1 and M0 has the value 10, then mode 2 is selected. And when the M1 and M0 has the value 11, then mode 3 is selected. I hope you all get the basic function of the bits of the TMOD register. The TMOD register is used to specify the timer mode of the 8051 microcontroller. The next SFR is the TCON register. The TCON stands for the timer control register. It is an 8-bit register out of which the lower 4 bits are used for interrupts and the upper 4 bits are used for the timer and counters, out of which the TF1 bit is set whenever there is the timer 1 overflows. The TR1 bit is set, that means whenever TR1 bit has the value 1, then the timer 1 enables. When the TR1 bit is reset, then the timer 1 is disabled. The TF0 bit sets, or when the TF0 bit has the value 1, that means the timer 0 flag, or sorry, the timer 0 overflows. Okay, the next bit is TR0. When this TR0 bit is set, then the timer 0 is enabled, and when the TR0 bit has the value 0, then the timer 0 is disabled. The next bit is IE1, that means external interrupt 1. That means whenever there is an interrupt from INT1 pin or the external interrupt occurs, then this bit is set. And whenever the interrupt is processed, this bit becomes 0. IT1 means it is used to generate the external interrupt on the INT1 pin. IE0, that means whenever there is interrupt from INT0 pin, then this bit is set to 1, and whenever this interrupt is processed, then it becomes value 0, that means it becomes reset now. The last bit is IT0. It is used to generate an interrupt on the INT0 pin. Okay, I hope you all get the basic idea about the TMOD and TCON register. Thank you.